Hi everyone, we're going to solve for our angle on the domain 0 to 2 pi, and these involve quadratic form. You're going to have to factor these. And for this video I'm doing the first 5. So basically I'm doing these right in there. I'm going to save the last 4 for a different video so the video's not so long. Alright, so I went ahead and put the unit circle on here. But you try to do these without looking at the unit circle so you can have it fully memorized. So when you have quadratic form, what you want to do is don't divide anything out. You're just going to factor. So for this first one, we're going to factor out a cosine. It's kind of like dividing, but you're not dividing, you're just pulling it out. You're not losing the divisor. So when you do this, you're going to get 2 cosine of x. So you see we did kind of divide here, but we didn't lose the divisor, so it's right there. And then cosine x divided by cosine x is just going to be 1. And that equals 0. So we have cosine, we do each piece here. We have cosine of x equals 0, and we have 2 cosine x plus 1 equals 0. So this one, you're going to subtract the 1 and then divide by 2. So then all you have to do is look at your unit circle. Where's cosine 0? Cosine is 0 at pi over 2 and 3 pi over 2 because it's at 0 there. So here we have pi over 2, x equals, and 3 pi over 2. And where is, oh, this is 1 over 2. So where is cosine x negative 1/2? That is where your x is negative 1/2. So that is going to be right here at 4 pi over 3. And right, where's the other one? Negative 1/2. It's going to be right here, which is 2 pi over 3. So if you have to write it as a solution set, and if we go in order, this is going to be pi over 2. You don't have to go in order, I'm just going to do it. And then we have 2 pi over 3. Then we have 4 pi over 3. And then we have 3 pi divided by 2. Alright? So that's basically the idea. Now we have one that's very similar. So don't divide both sides by sine x. That's going to be a big mistake, especially when you see this 2 there. So, you know it's quadratic in form. So you're just going to subtract sine of x from both sides. And then factor out a sine of x, just like we did with the cosine. And that would leave us with 2 sine of x minus 1 equals 0. So set this to 0, sine of x equals 0, and this piece to 0. So basically you have 2 sine x minus 1 equals 0. So you add the 1 and divide by 2. So where is sine of x 0? And again, you don't have to put these in order, so let's don't this time. So where is your y 0? It's right there and right there. So that is going to be at 0 and pi. And where is your y 1/2? So your y is 1/2 right here and right here, which is pi over 6 and 5 pi divided by 6. Alright, and the next one. This one is a trinomial. So this one's like saying 2x squared plus x minus 1. And if you factor that, you get 2x, x. We need a 1, 1. Since this is positive, this is going to be positive, and this is going to be negative. So instead of our x, it's cosine. So let's rewrite it. We have 2 cosine of x minus 1 and x plus cosine x plus 1 equals 0. This was equal 0. So set both pieces equal to 0. So for this one, 2 cosine of x minus 1 equals 0. You're going to get cosine of x. You're going to add the 1, divide by 2. And for this one, you're going to get cosine of x and subtract the 1. So where does cosine x equal 1/2? So that's where's your x 1/2, and it's right here and right here. So that's going to be pi divided by 3 and 5 pi divided by 3. And where does cosine x equals -1? So we're looking for your x at -1, and it's right here, and that's going to be at pi. All right, we got 2 more here. It's another thing. This is another trinomial. So we're going to do 2 sine of x and sine of x. And since this is a positive 1, it's going to be 1, 1. Since it's positive and this is positive, they're both positive. You can check for the 3. This would be 2 sine plus 1 sine. That does give us 3. So basically, we're going to set both of these pieces to 0. So if you set this to 0, you're going to get sine of x. You're subtracting the 1, dividing by 2. And for this one, it's sine of x, and you're subtracting the 1. And you merely just find where your y is -1 and -1/2. So where is y -1/2? Well, it's right here and right here, which is 7 pi over 6 and 11 pi divided by 6. And where does sine equal -1? Well, that means where does your y equal -1? Right there. And that would be 3 pi divided by 2. And for the last one, now this one's going to lead into the next video I do, but since these aren't the same, I'm going to use my Pythagorean identities, the fact that sine squared of x plus cosine squared of x equals 1. And I'm going to solve for cosine squared of x. So cosine squared of x equals 1 minus sine squared of x. And I'm going to substitute, wait. I'm going to do the other way. So let me go back. So we're going to do sine squared of x equals 1 minus cosine squared of x. So this is the one I'm going to use because I have a cosine here. So I want this to be in terms of cosine. So you're going to write 2 times 1 minus cosine squared of x equals 2 minus cosine of x. So distribute, you get 2 minus 2 cosine squared of x equals 2 minus cosine of x. Now I'm going to move everything over to the right, so and set it to 0. So you have 2 cosine squared of x, this is already on the right, minus cosine of x. Now what you're going to get here is the 2's cancel if you subtract those. Alright, so now we're going to do the greatest common factor, the highest common factor. Factor out a cosine of x, and that's going to give you 2 minus 2 cosine x minus 1. So when you set this to 0, you just get cosine of x equals 0. And for this one, you're going to get cosine of x, you add the 1 and divide by 2. So where does cosine equal 0? That means where does x equal 0? It's right here and right here. So that's going to be pi divided by 2 and 3 pi divided by 2. So that's that one. And for this one, where is x 1/2? It's right here and right here. I know it's quadrant 1 and 4. So that's going to be pi divided by 3 and 5 pi divided by 3. And that's it. The next set I do is going to be more of these involving our Pythagorean identity. Thank you. Have a nice day. Bye-bye.